Okay, so guys, today, yes, Deva has reminded about this topic. So Telnet and SSH. So let me start with Telnet and SSH. Okay, so you can write the heading VTY access. VTY access. You guys know about the console access. You guys know about the console access. How to log in to the router using console. Okay, so we have the router here and we have the console port. Okay, and you can connect the rollover cable, or suppose if at all you have the connector, then you can connect to the home port or the USB. If you have the connector and all, you can connect it using the connector to the USB. And you will have certain softwares, say terminal emulation softwares. Example PuTTY, you will take PuTTY and configure the router using the console. You know it, right? Now you're going to study the VTY access. VTY access means virtual teletype. It's virtual teletype. Virtual teletype. Okay, so VTY here is virtual. It means suppose we have already done the connection. Suppose that, say, let me take a topology. Okay, just a moment. Okay, so here let me take a topology. Suppose we have a router. Okay, now we have a switch here and we have a computer. Suppose two computers. Okay, now so let me again connect it, this one. Now let us assign an IP address for this network, which is suppose 10.0.0.0/24 network. Okay, and this gig 0/0/0 is assigned with an IP 10.0.0.1/24. And did I tell you how to assign IP for the switch? No. Okay, I'll tell you. So I'll tell you how to assign IP address for the switch. Suppose I'm assigning IP address 10.0.0.100 for the switch. Okay, and here I am assigning 10.0.0.3 and here I am assigning 10.0.0.4. Okay, so let me first assign that thing. So let me assign IP to the router. Interface gigabit Ethernet 0/0/0, where I'll be mentioning the IP address. Yes, 10.0.0.1, 255.255.255.0, then no shit. Okay, now let me give IP address to the computers as well. Suppose I'm giving the IP 10.0.0, say 2 or 3. Okay, and the submask is 255.255.255.0. Okay, now okay, just a moment again. Okay, so now this computer is assigned with 10.0.0.3. okay, 10.0.0.3 and /24, and now let me assign the IP to the switch also. So let me tell you how to assign IP to a switch. We'll go to the config mode, and where we'll be giving the IP like this: interface VLAN 1. The command is interface VLAN 1. You will study later, you will study what is VLAN and all. Okay, now just understand that this is how you're going to give the IP address to a switch. Now you're going to give the IP like this: IP address, say 10.0.0.100. Then you're going to assign the IP, so 255, sorry, the submask 255.255.255.0. okay, then you're going to give no shit. So the interface VLAN 1 has become up now. Okay, this is a virtual interface. You can't see this VLAN 1 and all. Okay, so I've just assigned an IP to the switch. For the entire switch, I have assigned an IP. So do show IP interface brief. So you can see here VLAN 1 has an IP of 10.0.0.100 and it is up bar up state. Clear? Okay, now so once you have set up these things, now you can go for the VTY access. You can go for the VTY access. So VTY access, it means, say if at all you are in, say, these router, these are in US. Okay, suppose these are in US, these devices are in US, and you are in India. You are in India. So if at all you got sufficient connectivity between your computer in India and the router in US, you can connect to the router. You can configure the router using the interfaces. It means the interface will act as a port. The interface will act as a port. Okay, so that's what VTY port. So VTY means it's virtual only. You cannot see it with the say naked eyes. Okay, so it's just the virtual concept. Okay, or you can say the interface, when it acts as a port, then it is called VTY port. Clear? Now, so if you want to do VTY access, you can go use, or you can go for two things. Either you can implement Telnet. You can go with Telnet, or you can go with something called SSH, secure shell. It's called secure shell. So you have Telnet and secure shell or SSH. The difference is that if at all you are configuring Telnet, whatever data that you send, you are trying to configure the router. So suppose you are entering the password here. So the password will be sent as the plain text. It will be sent as the plain text. It means whoever is there in the middle can capture the packets and read it and can get to know the password and all. So in the production you will be going with SSH only. So but we will be studying both Telnet and SSH. Okay, so first you can write the heading Telnet. Telnet. Okay, so in Telnet what we are going to do is that the first thing, only two things. Okay, so first we will check the connectivity. We'll check the connectivity. Suppose that we are doing, yes, the VTY access to the router. So from computer you want to access the router. So first you will check the connectivity from this computer, whether you have connectivity to the router. So you will go to the machine, you will go to this computer and you will ping it. Say ping 10.0.0.1 and you are getting the reply from 10.0.0.1 you are getting. Okay, if the ping is there, or if the connectivity is there, now you can try to Telnet. If you do Telnet, the command is Telnet space the IP address 10.0.0.1. Okay, the command is Telnet, then the IP 10.0.0.1. If you do it, if you try to do it, let me tell you what happens. I have tried connection to 10.0.0.1. Trying 10.0.0.1, it is open, but connection to 10.0.0.1 closed by the foreign host. Okay, it is, the connection is terminated or closed by somebody. It means the connection is closed by this router itself, because we haven't done any VTY settings here, any VTY configurations here. So if at all you want to Telnet, you have to do the VTY basic configurations. So let me tell you what to do. First you have to set a VTY password. First you have to set a VTY password. To set the VTY password, we'll go to the config mode. Then we'll mention line VTY 0 space 15. We'll mention it like this. Line VTY 0 space 15. Then you have moved into the VTY line where we'll be telling the password. Suppose the password is Cisco123. Cisco123. Then you will mention the command login. Exit. That's it. Clear? Now that you have mentioned the VTY password. Now shall we try to log in to the router using the computer? So we'll go to the computer. So previously when I telneted, I didn't get the connection. It was closed by the foreign host. Now I do the Telnet 10.0.0.1. Now you can see trying 10.0.0.1, it is open and it has asked for the password, which is the VTY password, which is Cisco123. Now you are able to enter the router. So now you can see you are in the computer only. Okay, you can see you are in the computer. Okay, and from the computer you can configure the router. So that means if at all you have the connectivity from India, you can connect the router, or you can configure the router in US. Okay, again if you try to configure, enable no password set. So in addition to VTY password, you must be setting the enable password or enable secret password. Okay, so let me set enable secret password here. Enable, just a moment. Okay. Okay, enable secret. Then suppose 1 2 3 4 5. Just mention enable secret. So now if you try to enter enable, it's asking for the password, which is 1 2 3 4 5. It is the enable secret password. So now that I've entered into the router, I can configure whatever I want. So suppose to change the host name, I can change the host name. Suppose say what do you say? I want to change the host name. Yes. Okay. So let me change the host name to Tiger. I can change it. Okay. So I am doing this configuration from the PC. That will reflect when you go to the router itself. So previously router was having the host name as router itself. Now when you check, the name has changed to Tiger. Clear? This is how you will configure the VTV access, or you will configure the Telnet. Clear? Okay. Now the same thing can be done in the switch also. The same thing can be done in the switch, and you will get access to the switch. Okay. Now if at all you want to do SSH, okay, so now if at all you want to do SSH, you can do the SSH configurations. Okay, to do the SSH, first thing that you need to do is to create a host name for the device. Create a host name. We have already set a host name to this device. Then the second thing that you will do is that you will create, or you will give a domain name. You will give a domain name. The command is this one: IP domain -name. Okay, then you will be giving the domain name. Suppose you are working in Cisco and you will be giving cisco.com. This is the domain name. Clear, guys? Okay. So we have set the host name, then we will set the domain name. These two things are mandatory. Okay. Now we will generate. So again, I told you that if you go with the Telnet, whatever that you send will be in the plain text format. Now if you go with secure shell or SSH, these whatever you send will be encrypted. It will be encrypted. For encrypting, you will have to generate a key. So let us generate a key. Okay, so the key will be generated using this command: crypto key generate RSA. Okay, crypto key generate is the command, and RSA is the protocol. Okay, reverse Shamir Aldiman. So this is the algorithm through which we will create a key. Okay, so crypto key generate RSA, and then it will ask for something. The name for the keys will be tiger.cisco.com. Okay, choose the size of the key modulus. That means you have to mention a key size, key length. So suppose that I am giving 1024. Okay, then you can see generating 1024 bit RSA keys will be non-exportable. So the keys are generated, and you can see the SSH has been enabled. You have enabled the SSH. Clear? Okay. Then the next thing that you're going to do is create a username and password, so that you can log in using this username and password. So Ashwin here. Okay, so username, suppose I'm creating just Deva. Okay, password, suppose Deva123. Okay, and suppose if I want, I can create another username. Okay, suppose Sajin, and password Sajin123. Okay, now we have enabled the SSH and all. Now we have to go into the VTY LAN and mention SSH should be used. Okay, for that, so we'll go to VTY LAN, line VTY 0 space 15. Then we'll mention, say, login local. Use the local credentials to login. Okay, then you will mention something like transport input SSH. Transport input SSH. Use SSH for this VTY access. Clear? Okay. Now, after doing this much, now I'm trying to do the SSH. Okay, so now let me go to the computer here. Let me exit. So now that I'm back into the computer. Now if I want to do the SSH, the command is SSH-L. SSH-L, then we'll give the username. Suppose I'm giving Sajid. Okay, then you are giving the command, the IP. So suppose 10.0.0.1. Okay, so you can see the password has been prompted. The password is prompted. So this is the password is Sajin 123. Okay, SAJIN 123. Okay, now that I have entered into the device. Clear, guys? So this is how you are going to do the SSH connection. Okay, so this is how you are going to log into the device using VTY access. Any doubts? Clear? Okay. These are the basic thing, guys. Basic levels of SSH and all. Okay. So do you want the commands?
Yes, this is used for more secure connection.
Is it used for?
More secure connection.
Yes, exactly. So we will not be doing Telnet in the production. So wherever you go, you will be doing the SSH. Okay. Yes. If at all you need the commands, these are the commands. Cisco 123. No. 1 2 3 4. Okay. So now show history. Do show history. Nope. Okay. So this is how you will. Yes, IP domain name. But you have to mention that you have to create a host name as well. Okay. So the host name is Tiger.
So how do you choose the domain name?
Domain name is usually the company name only. Okay. So it means, say, domain. Let me tell you what is domain. So here, domain is an area. It's an area which is under the control of a single person. It might be in the control of, say, senior network admin, or it might be in the control of, say, some other architect, say network architect, or whatever, whoever is responsible. So these, say, you will have the switch and you will have routers and all. So these computers will be part of the domain, and these switches and these routers can also be part of the domain. Clear? Okay. It means that it comes in a single administrative area. Yes. So guys, for Telnet the command is simple. Okay, so for Telnet you just need to give the VTY password. Okay, we'll go to the line VTY. Okay, you will mention, if at all you need Telnet, you can mention Telnet, transport input Telnet. Okay, and then don't forget to set the enable password. You can note it down, guys. Just give me a minute. Yes, so this is how you do the things. Okay, now done. Okay,
Can we telnet from system to system or?
system to system you can't do telnet. For that, if at all it's Windows, then you can go for the remote desktop connection and all. Okay, so yes, now so here, or else it should act as a telnet server. Okay, so we'll be going with the remote desktop connection, those things and all. Okay, now so here we have done this, and the same can be done to the switch also. The same can be done to the switch. Suppose that I'm setting, say, the same configuration. Say, let me copy and paste. So suppose the domain name, so the host name, suppose I'm changing it to line. Okay, and say suppose and crypto keygen 1024. Okay, so let me go to the switch and let me paste it in the switch first. Okay, yes, now that you have done all the configurations in the switch. Okay, so if from the router, even from the computer also, you can telnet, or you can do the SSH to the switch, or if at all you want to SSH from the router, you can also do it from the router also. So suppose that you are in the router. Okay, you want to do the SSH, then you can go to the privilege execution mode and you can mention like this: SSH then -L. Okay, then the username, suppose Sajid, and say the command is, suppose the IP 10.0.0.100. Okay, and ask for the password. So I suppose the password is Sajin123. Now we have entered into the switch. The switch has not been configured with the enable secret password or enable password. That is why the error is showing. Clear, guys? Okay, so to the switch also you can configure these things, and you can access the switch using these commands. Clear? Okay, so this is the telnet or SSH connection, and this is the VTY. Now we'll get back. Okay, now we'll get back to switching. So we were discussing about switching. Okay, now we'll discuss about switch interface state. Switch interface states. Okay, so as you have written the heading, maybe in the back side of your notebook you can write down a homework. You can write down a homework topology. Okay, so you can write down a homework topology. R1. Okay, and this is R2. Okay, and this is, suppose this is a switch. This is the network. Suppose this is having the IP 10.0.0.0/24 network, and this is having the IP 10.1.0.0/30 network. This is having 10.0.1.0/24 network. Okay, now let me tell you. So guys, you can listen here. Okay, these computers need to take the remote access of this switch 1, this router 1, router 2, and switch 2. Clear? Okay, so doing in switch 1, R1 and R2 is easy. Doing it in switch 2, you need, what do you need?
OSPF or
Yes, you need routing. Okay, for taking this configuration, taking router 2 also, you need routing. So perform either static routing or you can perform the OSPF, no issues. The only thing I need is the connectivity. Okay, so here what you need to do is that I need to get the telnet and both the SSH connection from this computer to switch 1, then to router 1, from this computer to directly to router 2, and from this computer directly to this switch 2 as well. For switch 2, You will not get it. Go with the packet flow. You will understand. And let me know what the issue is. Clear? Okay, that's the homework. Okay, yes. Now guys, now we'll move on to the switch interface state. Switch interface state. So you got multiple states for the switch interface. Let me tell you here. So if you connect, suppose if you connect a computer, you can see this interface, it has not come up. It is in orange or amber color. Okay, it will take some time for this interface to come up, maybe 30 seconds. Okay, it will take some time for this interface to come up because this interface say has different states. So let me tell you about the states here. Okay, so you got many states. A blocking state. It's called blocking state. Blocking state. Then the second one is called listening state. Then the third one is called learning state. Fourth one, forwarding state. And the fifth one, disable state. These are the 5 states. Switch interface state. Blocking, listening, learning, forwarding, and disabled. So blocking state will be there for 20 seconds. It will be there for 20 seconds. And this 20 seconds is calculated by using a timer called maximum age timer. Maximum age timer. Okay. Now, listening state, it occurs for 15 seconds. And this 15 seconds is noted by the timer forward delay timer. Forward delay time. And the third one, learning state, also for 15 seconds, which also is therefore, or which is tracked using the forward delay time. Okay, now let me tell you, in these 3 states, the user defined frames. What is it? User defined frames. That suppose that I am sending certain packets. Suppose that I've just connected it. Okay, I've just connected. Okay, so you can see the amber color, right? So if I execute one command, the command is show spanning -tree. Okay, you can see, yes, it has come up. 13. That is 13 designated. Okay, it's in listening state. You can see the state is listening state. And again you can see after some time it is in learning state. And again after some time, after 15 seconds, you can see it has come to forwarding state. Okay, so what happens is that, so during listening and learning state, or blocking, listening and learning state, they will not forward the user defined frames. User defined frames means, say here, if at all you are sending a ping, you are sending say ping from this computer to this computer. So that is user defined frames, where the user is, say, sending something, right? So that is the user defined frames, or the frames generated by these computers. Okay, yes. So these frames will not be passed or will not be forwarded during these three states: blocking state, listening state, and learning state. Clear? Okay. Now, afterwards, you will come to a state called forwarding state. This is where the switch interface forwards the user defined frames. So maybe for after 30 seconds, it will move to the forwarding state. And if it's in the forwarding state, then they'll start sending the user defined frames. Clear? Okay. Now, you got one more state called disabled state, which happens if you make the interface manually shut down or because of some errors. Clear? These are the states.
Forwarding state, the timer is maintained.
Forwarding state, no timer is there, because it stays in the forwarding state as long as you make it down, or as long as some errors happen, or as long as the interface goes down. Okay, so in forwarding state you do not have a time. Okay, yes. Now guys, now let me tell you the next thing. Switch. Now, did I teach you about the CAM table, MAC address table? Sure.
You told only it maintains MAC table.
It maintains MAC table. Okay. So, did I tell you how to how they will? I suppose I have taught you, right? How the MAC table is filled, right? I've taught you. The MAC table is filled based on the incoming frames source MAC address. If at all a frame is received in a switch interface, then that is called the incoming frame. So the incoming frames source MAC address will be updated in the CAM table that I have told you, right? And the switching process also I have told you. Okay. Now, again write the heading switch functions. Switch functions. Switch functions. First function you already know. Forward. Or you can say switching, means it's the forwarding of frames. Okay. Forwarding means forwarding of frames or forwarding frames. Okay. The second function is learning. It is learning. Learn the MAC addresses or update the CAM table. Okay. Learn the MAC address and update the CAM table. I mean, learn the source MAC address and update the CAM table. Did I show you the commands of how to view the CAM table? No. Okay. To view the CAM table, so here suppose let me try to communicate. Okay. So let me try to. Okay. So we have tried to communicate, and to view the CAM table, we will go to the switch privilege mode and execute the command show MAC space address hyphen table. This is the command to view the CAM table. So it shows now, it shows only two devices. Okay, one is the machine laptop and the other is the switch, because recently only two machines communicated. So after this time this will expire. Okay, after certain time this will be like expire and it will be removed from the CAM table. Clear? So you have to, because say when I try to ping to the switch, okay, maybe let us see. Okay, it is from F0/3 and the other is from F0/1. So in F0/1 this computer is sitting, and in F0/3 the router is also sitting. Okay, so what happens, let me tell you, from the router. Okay, so what happened is that we have accessed from the computer we have accessed the router. From the router you are accessing the switch. Getting it? Because say we have done the SSH. Then from the router again you are doing the SSH here. Clear, guys? It's not a fresh SSH. Again from the router only we are establishing SSH from access to the switch. Got it, guys? And that's why two traffic. So that's why these two devices are there. If at all this machine also communicates. Okay, so if at all this machine, suppose ping 10.0.0.1. Okay, so now one more device will come. So one more device which is in F0/2 will also come. Clear? Okay. Ashwin? Okay. Now, again, where's my specs? Now I can see clearly. Okay. Now, so this is how you see the MAC address table. Now let me tell you. So learn the source MAC address and update the CAM table. And the third function is called avoiding layer 2 loop. Avoiding layer 2 loop. Avoiding layer 2 loop. Okay, so first you have to know what is this layer 2 loop. So let me tell you about layer 2 loop. So here suppose you got two switches, S1 and S2. You got two switches. Wanna turn off? Sure. Okay. So now suppose you have connected it like this. Connected it like this. And again another connection. It's like this. Connected like this. Okay. Now guys, done. Okay. Within just 5 to 10 minutes I'll give you a break. No worries. Okay. So here, okay, it's cold, right? No. Suppose I'm feeling cold. Okay. Yes, guys. So if at all you're feeling hot, you can again decrease. Okay. So now, suppose here in F0/1 this machine is sitting. Okay. In F0/2 this this S1 is connected to S2. Okay. And via F0/3 also this is connected to switch 2. Now S2, suppose F0/1, yeah, F0/01 or whatever. Okay, F0/2. Okay. Now, so this switch 1 will be having a CAM table. Switch 1 will be having a CAM table. Switch 2 also will be having a CAM table. Now suppose this computer has got a MAC address 0001 8211 B222, some MAC address. Okay. Now suppose this computer is sending a broadcast. The computer is sending a broadcast. If the broadcast is sent, say what happens is that if the broadcast is sent, it is sent to the switch. It is an incoming frame for the switch. And you guys know incoming frames, source MAC address will be updated in the CAM table. So this MAC address will be updated in the CAM table. So 0001 8211 B222 will be updated in the CAM table. It will be updated. It received the frame via F0/1, so it will update it as F0/1. Got it? Okay. Now it's a broadcast, so it will be sent to this interface, and it will be sent to this interface as well. Okay. So considering this one, the red one. Considering the red one, it will be received at switch 2. Okay, via F0/1. So this switch will also update that CAM table. It's an incoming frame. It will update the incoming frame's source MAC address. So it will update it like that: 0001 8211B222 is sitting in F0/1. He has updated it. Okay, now this is a broadcast, so it will be sent through F0/2 as well. It will be sent through F0/2. Okay, now it is received at switch 1 here. It is received at switch 1. Now the switch 1, what he will do is that he will receive the same frame from F0/3. So he'll update the source MAC address. It's an incoming frame, he'll update the source MAC address. So what is the source MAC address? This itself is the source MAC. So this time he'll update, okay, now this machine is not sitting in F0/1, but he is sitting in F0/3. Got it? Now, again it's a broadcast, it will be sent through this interface, it will be going like this. Clear, guys? It will form a loop in the clockwise direction. Form a loop in the clockwise direction. Okay, now considering the blue frame, considering this blue frame, so I told you it is this actually frame is received through F0/1, and then it's a broadcast, it is sent through the F0/2 and is sent to F0/3. Okay, F0/2 we have discussed. What about F0/3? It will be sent through F0/3. It will be received in switch 2 via F0/2. So he'll update. Now this machine is sitting not in F0/1 but in F0/2. Then it will be sent out through this interface. Okay, and will be received by S1 via F0/2. So he'll update now F0/2. Now not in F0/3 but in F0/2. Okay, so when he updated it as F0/2 again, so what happens is that this will also keep on going like this. It'll keep on going like this. So you have another loop in the anti-clockwise direction. So what happens is that when switch 1 updates it as F0/2, by that time he will receive this red frames. He'll receive these red frames via F0/3. So he'll update. Now he's not in F0/2 but in F0/3. When he update that, he might receive the blue frames. He might receive the blue frames through F0/2. So again he'll update F0/2. Again here he will receive F0/3, 2, 3, 2. He'll update it like that. Okay, so the MAC address flapping will occur. MAC address flapping will occur. It will occur here also. Whenever he is receiving the blue frames via F0/2 and he'll update it as F0/2, then he will receive the red frame. Then he'll update it as F0/1. Again he'll update it as 2. Again he'll update it at 1, 2, 1, 2, 1, 2. Like that, the flapping will happen. So the ultimate result is that the switch will become unstable. Okay, or it will become unstable. So that switches will no longer work efficiently. It will be stuck. So whatever, if at all you are trying to send a frame here, suppose you are trying to connect to internet, you will not get the connection. It will be entirely it will be stuck. Okay, so this is the loop and hence it needs to be avoided.
So will collision occur?
No, collision will not occur, but say here collision, because collision occurs in half duplex only. Now that we are talking about full duplex thing. Okay, now so here what happens is that the loops will occur, and so we'll have to, if at all you want, you can turn it, you can decrease. Okay, so the loops will occur and you can say avoid the layer 2 loops by implementing or by enabling a protocol, or a protocol is used to avoid the layer 2 loop, and that protocol is called, you might have heard of it, spanning tree protocol. That is called spanning tree protocol or STP. It is used to avoid the layer 2 loop. Okay, now let me tell you, by default STP is enabled in Cisco switches. So by default these loops will not happen in Cisco switches. Clear? Any doubts? Okay. So now we'll give you a break, small break, because after the break we are going to study about spanning tree protocol. Clear, guys? Okay, so we'll give you a break till 6:36 p.m. Okay. Yes. Okay. STP. Okay, so now spanning tree protocol. Okay. So now, before telling you, we'll go with some terms. The first term is called switch ID. It's called switch ID. It's called switch ID. So you know about router ID. So similarly you got switch ID. So switch ID is used to differentiate the switches. So it consists of two parts. The first part is called the priority, switch priority. Switch priority. And the second part is called switch MAC address. Switch MAC address. So the priority number, it's a 16-bit value. It's a 16-bit value. Okay, and the MAC address, it's a 48-bit value. It's a 48-bit value. So let me draw a topology here. So you suppose you got three switches, S1, S2 and S3. You got three switches. Now these three switches are connected like this. Switches connected like this. Now here we have used F0/1, and here suppose F0/2, here F0/1, here F0/2, and here F0/1, and here F0/2. Suppose this is the connection. Okay, now so here each switch has got a switch ID. Each switch has got a switch ID. We can differentiate the switches using the host names S1, S2 and S3, but the switches will not be able to differentiate with the, say, host names. They'll use the switch ID, which will be like this. So it will be like this. So here give me, say, suppose, so I told you there's a priority number. It's a priority number. It's a 16-bit value, and its value can range from 0 to 65,535. Its value can range from 0 to 65,535. Suppose this is the switch ID for switch 1, 32768. So then the MAC address 0001 A2A2 B3C4. This is the switch ID. Okay, I told you it consists of two parts, the priority or the priority number and also the MAC address. So now let me tell you, so I told you the priority number will be having the value from 0 to 65,535. The value will be in between these three. Now, so by default all the Cisco switches will have the priority number 32,768. Okay, now suppose you got S2, and suppose S2 is having something like this. The priority number is 0 and the MAC address is 0002 A4B4 C3D3. Okay, now the switch 3 has a MAC address something like this, say 32,768. Sorry, not the MAC, say switch ID. So then the MAC address is 0004 A2B1 C3D4. Some random MAC addresses. Okay, now so these are the switch ID values. So this is the switch ID of S1, this is the switch ID of S2, and this is the switch ID of S3. Okay, now where is it? Now the next term, the second term is called root switch. It's called a root switch. Root switch. So in the switch topology, we will select a leader switch. We'll select a leader switch, and that switch is called a root switch. Okay, or technically speaking, so the switch which has got least switch ID, the switch which has got least switch ID will become the root switch. Clear? Okay, so now let me tell you. So here you have S1, S2 and S3. So these are the switch IDs. Okay, now of S1, S2 and S3, which is having the least switch ID? The least switch ID is S2, because at first they'll check for the priority number. They'll check for the priority number. If the priority number is 32768 here and 32768 here and 0 here, that means S2 is having the least switch ID. What if the priority number is something like this? What if this priority number is also 32768? Here also the priority is 32768. If the priority number is same, then they will check on to the MAC address. Whichever switch is having the least MAC address, that switch will be considered as the root switch. Getting it? Okay, so here who will become the root switch in this case? S1 will become the root switch, because it's 0001. Okay, everyone is having 32768 as the priority, then they'll check the MAC address. So the MAC who is having the least MAC 0001, S1 is having the least MAC. So S1 is the root switch. S1 is the root switch. Clear? Okay. Now the third thing. So what we have did is, so first thing we have found out the root switch, or find out the root switch. How did we find out? Least switch ID. Least switch ID, or you can say least priority. Okay, least priority. If at all the priority is same, then we'll check least MAC address. Clear? Okay, that's the first one. Now second one we'll discuss. Before that, we have another term called non-root switches. Non-root switches, obviously you can guess. Non-root switches are those switches which are not the root switch. So S2 and S3 are the non-root switches. Okay, yes. Okay, now the fourth term, which is called BPD. It's called BPD, or it's called Bridge Protocol Data Unit. Bridge Protocol Data Unit, BPD. Okay, now so S1 is the leader switch, or S1 is the root switch. Okay, now what happens is that, say S1 or all the switches. Okay, so the usual example, let me tell you the usual example. Okay, suppose we have students. Okay, now we got Vaman here. Okay, we got Deva. Okay, we got Anish. Okay, we got Ashwin, we got Sajin, and okay, one more guy. Yes, Susmit. Okay, now so you guys have come first. Suppose, say those four guys, leave that, they have studied together. Okay, they have studied, say, in different colleges, suppose. So now when you come first time to the class, you will be thinking, suppose Susmit is the college topper. He's the college topper. Okay, so he'll consider himself as the college topper. So I'm the college topper. I'm awesome guy. So I must be made the leader. Right. Now Sajin. Sajin, suppose he has mustache and he has, say suppose, muscle and all. Okay, so he'll tell that, okay, sir, I am the muscle man here. So I am the leader here. Okay, now Ashwin. So Ashwin. So Ashwin, suppose he passed from IIT or something. So he'll say, sir, I am an IIT product, so I need to become the leader. So everyone wants to become the leader. So what everyone tells is that, say, Vaman will also tell, okay, sir, I am, say, whatever, say, suppose he's expert. Okay, he has done the CCNA, says, multiple times. Okay, say, suppose he has completed and he has come for revision. I've already completed CCNA, sir, so I should be the leader here. Okay, like that. So what happens is that, say, everyone will start telling that, okay, I am the hero here. I am the hero. So Vaman will tell, Deva will tell, say Anish will tell, say Susmit will tell. So everyone will tell each other that I am the hero. Okay, but suppose we got Anish. Suppose he is working for 10 years. He's working for 10 years. What's your age?
23.
Okay. Now, suppose he's working for 10 years. Okay. So now, he's a brilliant boy and he's working for 10 years. So, I have decided this Anish should be made the leader. Or you guys have understood. So, what happens is that when everybody, say, Deva will tell Anish that he's the leader, or he wants to become the leader, or he's the eligible guy to become the leader, Vaman will tell. So everyone will share all the details with each other. So Anish will also tell Ashwin, okay, I am 10-year experienced guy, so I need to become the leader. So Ashwin will understand, okay, I am just an IIT product, but here we got Anish who has worked for 10 years, who is actually eligible to become the leader. So again Ashwin will tell Sajin, hey Sajin, you are nothing. The muscle and all, it's just nothing. We have 10-year experience guy. Okay, so Sajin now will tell, say, Vaman. Okay, Vaman, so you are nothing here. Say, Anish is the best. Okay, so it propagates. So in the switch topology, everyone will get to know about who is the root switch. Okay, so here the same thing happens. At first, everyone will start sending BPDU. BPDUs are those messages which contain spanning tree things. Okay, so it contains a root switch ID. It contains sender switch ID. So a root switch means, and many more things. Okay, root switch ID, sender switch ID, etc. So now okay, suppose, so what happens is that S1 will send the BPD telling that I am the root, and I have sent it and I am the root. Now S2 will, at first he will also send the BPD telling that I am the root, I have sent it. Okay, S3 will also send it. I am the root, I am sending. But when S1's BPD is received at S2 will understand S1 is having better capability to become the root switch. Then what he will do is that he will propagate the BPD. He will propagate the BPD from this eligible guy. Okay, so again, so everything will be propagated. Getting it? So at last S2 and S3, everyone, all the switches in the topology come to know that S1 is the root switch. Clear? Okay. So now, so that is the BPD. BPD are messages which contain spanning tree information. Okay. Now the next term is called port coast. It's called port coast. Port coast. Port coast. So port cost here means, suppose you got S1, you got S1. Suppose instead of S1 we have the leader. Who is the leader here? Anish is the leader. Anish is the leader. And we have, say, Sajin here, the muscle man. Okay, and we have Susmit. Okay, so Anish, I have made him the leader. So Anish will instruct several things. He will tell, so whatever Anish will tell, it needs to reach you guys, Sajin and Susmit. Okay, so Anish will be telling something, and for Anish to call Sajin, from Anish to call Sajin, he, suppose he is using some Jio connection and he is using some Airtel connection, or suppose not Jio, some BSNL suppose. So if at all he wants to call Sajin, he needs to spend, say, some value, say suppose 5 rupees. Okay, or he has to say he will have to spend some rupees. Similarly here, in order to reach the BPDUs, in order to reach S2, they have a cost there. They have a cost. Okay, the cost is actually, so let me tell you. So for Ethernet, the cost is equal to 100, or the port cost. This value is called port cost. The port cost is equal to 100. For fast Ethernet interface, the port cost is equal to 90. For gigabit Ethernet interface, the port cost is equal to 4. For 10 gigabit Ethernet interface, the port cost is equal to 2. These are the port cost values. Okay. Okay, now, so here, as you are using, okay, Sajin, if you want to write, you can write it. Ethernet 100, fast Ethernet 19, gig 4, 10 gig 2. Okay, yes. Now, so here the cost is 90. Okay, for fast Ethernet the cost is 90. Both end are fast Ethernet. So the cost is 90. Okay, so here also the cost is 90. Here also the cost is 90. The cost is 90 now. Okay, now suppose, so coming back to the same thing, say Anish, say Sajin, Susmit. Okay, so Anish can send, or Anish can tell something to Sajin. You can tell something to Sajin. Now that will cost suppose 19 rupees. Okay, now Anish can tell something to Susmit. That will also cost 19 rupees. Now, or instead of spending this 19 rupees, Anish can say tell Sajin, and Sajin can tell Susmit. Right, so again, what about, say, if Sajin is calling Susmit, that will also cost 19 rupees. So if at all something needs to be conveyed to Susmit, Anish can convey it directly by spending only 19 rupees, or he can spend 19 plus 19 rupees, which will be 38 rupees. Right, so this adding this value, this adding this cost value, or when you add this value, it is called path cost. It is called path cost. Okay, so this is the path cost value. Sixth is path cost. When you add the port cost, you will get path cost. Okay, now Okay, guys. Yes. Now let me tell you here. So Anish wants to tell something to Susmit. Anish wants to tell something to Susmit. He can either spend 38 rupees or he can spend 19 rupees. Which one will Anish go for? 19 rupees only. So he'll go for 19 rupees. Clear? So the concept is that whatever Anish is telling, it needs to reach all the others. Whatever Anish is telling, or whatever the root switch is sending, what the BPDUs which root switch send is called the superior BPDUs. It's called the superior BPDU. Okay, it's the BPDU sent by the root switch. So the superior BPDUs needs to reach all the non-root switches with least path cost. With least path cost. Okay, so now if at all, yes, so if at all Anish is telling, or Anish is going with the 38, okay, 38, or say Anish can go with the 19 as well as 38. Now if Anish is going via this 38, then he'll or Susmit will receive the call in his Airtel number. In his Airtel number. If Anish is spending 19 rupees, he will receive the call, or Susmit will receive the call in Jio number. Okay, so Anish will only consider this path with least value or least cost or least path cost. Going via that path, say Susmit will, or the information, suppose, just as an example, Anish wants to inform Susmit that tomorrow is a holiday. Just an example, tomorrow is not a holiday. Okay, so now Anish just wants to inform Susmit that tomorrow is a holiday. So he is gonna call him in the Jio number. So Susmit, he get to know that tomorrow is a holiday from Jio number. So that means to contact the leader, now he will use Jio number only. Getting it? And that number is called, say, the leader number. He'll consider it as the leader number. Or through this SIM, he can connect to the leader with least path cost. Getting it? Going with the technical things, again here. Okay, here. So S1 can send the superior BPDUs to S3. S1 can send superior BPDUs to S3 either via this path. If it is sent via this path, then the path cost is 38. Or he can send via this path. Okay, this path, the path cost is 90. Then say going with the lesser path cost, he will reach S3's, the non-root switch F0/1 interface. Or you can say S3, in order to reach the root switch, can contact the root switch through this interface. Or the opposite also, the same thing. Okay, if at all the root switch is sending the superior BPDUs, it will receive at S3 with the least path cost using F0/1 interface. And that interface is called a root port. It's called root port. It is the port through which it will contact the root switch with least path cost. Got it? Okay. So the next term is called a root port. A root port. You can write it is the interface of a non-root switch. It is the interface of a non-root switch through which it will receive the superior BPDUs. It will receive the superior BPDUs with least path cost. With least path cost. Okay. Yes. So F0/1 here, it is the root port of S3. So what is actually the root port? It is the interface of a non-root switch, or all the non-root switches will select an interface. All the non-root switch, S3 will select, S2 will also select an interface through which it receives the superior BPD with least path cost. Clear? Okay, so suppose, just give me a minute. Yes.
What if there were a switch in between S2 and S3?
Between S2 and S3. Okay, we'll come to that. No worries. We'll discuss. Okay. Now, we'll discuss it later. Okay. Now, so the second thing is that, where is it? We'll find out the root port of all non-root switches. Okay. How did we find out? Using least path cost. Okay, so this is, we have found out the root port of S3. Okay, for S3 this is the root port. Okay, now we have to find out the root port of S2 as well, shall we? Okay, to find out the root port of S2, superior BPDs can be sent either via this way, then the path cost is 19, or it can be sent via this way, then the path cost is 19 plus 19, which will be 38. So which path will be chosen? The leftward or the rightward path? Leftward path will be chosen, because it is having least path cost. So going via that interface, you will reach switch 2's F0/2. So that will be the root port. Got it? Okay. So again, so this will be the root port here. Okay. Now we have a doubt, right? Anish has a doubt. What if okay, so let me just draw it here. So Anish has a doubt like this. What if we have another switch? We have another switch S4. We have another switch S4, which is in between this S2 and S3. Suppose F0/3 is connected here, F0/3 is connected, and F0/1 and F0/2 is connected. So here the port cost will be 19. Here also the port cost will be 19. Any doubts in this? Okay. So now, now we have to find out the root port for S4. To find out the root port for S4, you can either send the BPDs via this path, the left path. Going via that path, the path cost will be 19 plus 19. So the path cost here will be 38. Okay. Now going via the rightward path, here also, yes, the cost is 19 plus 19, 38. What if the path cost is same? Right? If the path cost is same, let me tell you. Now you will consider the next thing, which is called, if the path cost is same, we will consider the next thing called least sender switch ID. Least sender switch ID. Okay, least sender switch ID. Who are the senders here? For S4, the immediate sender is S2 and S3. The immediate senders are S2 and S3. So among S2 and S3, who is having the least switch ID? Who is having the least switch ID? S2 is having the least. Why S2 is having the least switch ID? MAC address, exactly. So here 0002 and here 0004. So this path will be selected. The path with least switch ID will be selected. So that means this path will be selected. That means you are going via that path, you will reach S4's F0/1. And so S4's F0/1 will be the root port. Clear? Okay. Now I have a doubt. Suppose here on the top you have another switch S5. So here you got F0/10, here F0/5, here F0/5 and F0/10. Okay, now here the path cost is 19. So the path cost ties here. The path cost has become a tie. If the path cost has become a tie, I told you the second thing is the least sender switch ID. Going via both the path, who is the sender? S1 itself is the sender. For both the path, S1 itself is the sender. So there also you got a tie. Right? Everyone?
Yes.
So Smith? Okay. So now, if at all there is still a tie, then you will go with the third one. It's called least sender port ID. Least sender port ID. So sender port ID. Who is the sender here? S1 is the sender. Sender has the ports F0/10 and F0/5. Of which one is the least? F0/5 is the least. So that path will be considered. And going via that path, you will reach F0/10 of switch 5. So F0/10 of switch 5 will be the root port. Clear? Any doubts? Okay. So this is the second step. Find out the root port of all the non-root switches. Okay, so we have found out the root port for S2, S3, S4 and also S5. Clear? Now the next thing. The next term is called the last term. Okay, just a moment. Give me a moment, guys. Okay, so now the last term, which is called, so this one I didn't tell you, so root port, and the eighth one is designated port. Designated port. Okay, so the next step is to find out the designated port. So the third step is to find out the designated port for all the LAN segment. Okay, so root port was for all the non-root switches. Now designated port is for the LAN segment. LAN segment means link. It means link. So how many links you have it here? You have one link, second link and third link. You have 3 links. For each link you will have to find the designated port. So now let me tell you what is designated port. It is a port through which you will send the superior BPDU through that link. Okay, so let me again tell you. So this is S1. So whatever BPDU that S1 is sending is the superior BPDU. So S1 can send the superior BPDU to this link via its own interface F0/1. Okay, or he can send it via F0/2 of this link. Getting it? So if it is sent through its own interface, the path cost here will become 0. Okay, the path cost will become 0. Or else the path cost will be, you will have to come through this link, you will have to come through this link. So 19 plus 19 with path cost of 38, you will have to send it. Okay, so let me tell you a simple thing here. Okay, considering your root switch, all the interfaces of the root switch will be designated port. Okay, that is for sure. Okay, so this will be the designated port, this will also be the designated port. That is easier, right? So considering a root switch, all the interface of the root switch will be designated. Okay, now let me tell you one more shortcut. If you have the root port here, if you have the root port, opposite to the root port, you will always have the designated port. Getting it? So you can either do it in two ways. Either say, if at all it's the interfaces say directly connected to, or its own interface, the root switch own interface, then that will be the designated port. Okay, or say you can calculate like this also. Opposite to the root port, you will always have designated port. Got it? Okay, so let me tell you. So again, so this will be the designated port. Okay, this will be the designated port for this link. For first link we have found out the designated port. Now for second link also we have found out the designated port. Got it? So designated port is usually found out by checking the least path cost. Okay, now what if, so now we need to find out the designated port for this link, the third link here. So if you need to find out the designated port for the third link, let me tell you. So either it can be sent through S2, okay, and through its F0/1, this superior BPDU can be sent to the link, and the path cost will be 90. Anyone getting confused? Sure? Okay, then almost done. Okay, so or else you can send the superior BPDUs to that link through S3. Then the path cost is 90. So what if the, yes?
Since it is been sent to the own address, the path cost will be 0.
No. So now it is sent through F0/1. It has reached S2. Then it is reaching this link. Previously we were not considering that. We just previously our intention was only to reach this link. That is why the port cost was 0. Clear? Okay. So now, so to reach this link, you got the path cost of 90. Okay. Or you got another path cost of 90. So the path cost has become a tie. If the path cost has become a tie, then of course you know it. Say the second method will be, yes, they'll check the least sender switch ID. Okay, so who is the sender of to these links? The senders are S2 and S3. So who is having the least switch ID? S2 is having the least switch ID. So this interface, S2's interface, will be considered as the designated port. It is considered as the designated port. Clear? Okay. Now let me tell you, if this is considered as the designated port, okay, now so what have we done? We have calculated the root port for all the non-root switch. We have two non-root switch, S2 and S3. So we have two root ports. Okay, now we have found out the designated port for all the LAN segment or all the link. Okay, we got 3 LAN segment. We have found out 3 designated ports for each LAN segment. Done. The last step, the ultimate step. Okay, so the fourth step is that move all the unnecessary or move all the root port and designated port to forwarding state, while the unnecessary ports moved into blocking state. This is the last and final step. Okay, now shall I?
Yes.
Okay, the last and final step says, say the root port and designated port. That means this port, this port, this port, this port, this port. These interfaces will be moved to the forwarding state. Okay, and say you can see this interface, which is neither the designated port nor the root port. This port, so here, this one will be moved into the blocking state. It will be moved into the blocking state. Okay, so what happens is that, okay, so only these interfaces which are moved into the forwarding state passes the user defined frames, whereas this interface which is in the blocking state will not forward the user defined frames. As a result, let me tell you what happens. If at all you got a computer here, he is sending a broadcast, it will go like this and will get blocked here. Okay, and if it is going like this, it will get blocked, and so no loops will be formed. This is the working of spanning tree protocol. Clear?
Yes.
Yes. Any doubts or any confusion? Anything? Okay. What about online, guys? Everyone got it? Padla, Selva, Rakesh, Satish, Subhash. Okay. Okay, Rakesh, I suppose you don't have any doubts. Okay, yes, Selva. Okay, Subhash. So, this is one of the toughest topic. Yes. Okay. So, this is what it is. So, then we still have 10 more minutes.
So we will be doing the STP or automatically doing it?
It will automatically, the switches will automatically do it. So when you connect, tomorrow I'll show you. Okay, tomorrow, so when I say, when you connect it, the switches will, the switches will automatically run the STP, and they will find out the root port, they will find out the, first they will find out the root switch. Then they will find out the root port, the designated port and all, and they'll move these interfaces to the forwarding state, while the unnecessary ports are moved into the blocking state. It will be automatically done by the switches. You don't have to do anything, but you can customize it. The customization tomorrow you will study. Clear? Okay. So this is what it is. Okay. So we'll get back tomorrow. Okay. Yes. So thank you guys. See you tomorrow.
Thank you, sir.
Thank you.